kind of keep it simple if we can. The first one, you have a little bit more on yours than I do. We laid this out. This is an isosceles triangle. So when you drop your perpendicular line, you bisect that base in half. So this base becomes 4 and 4. These angles are the same because this is an isosceles triangle. Now you only need one triangle. They're congruent triangles. So if we're looking for the height of this guy, the guy that makes the H, the perpendicular line, you have an angle of reference, you need the opposite side, and you already have the adjacent side. So you're looking at tangent. And so the tangent, set it up, opposite over adjacent, cross multiply. 3 decimals. Whenever we round to 3 decimals. If it's angles, we're going to say exact values whenever we deal with the special right triangles. But if you're looking for sides, if I asked you for exact value, it would have your special triangles with the radicals. But these guys, no, they're not special angles. So 3 decimals. You okay with this? Stop me if we're not seeing it. Okay? So now the next one. I love these pictures that they give. So it's really good uses for this. And submarines use these all the time. They send their sonar down and it bounces off of something, and they use trig measurements with angles to figure out how far away, the distance, the depth, and everything else. The sonar is bounced off here, and we're looking for how deep is the submarine. Now, the submarine is down here. Do we measure the submarine's depth this way? Nope, we measure the submarine's depth with our perpendicular line right here. So a number of ways you can set up your triangle. If you set it up that way, that's fine. You're looking for the depth. You still have your angle. You're looking for opposite over hypotenuse. If you set it up this way, absolutely the same way. This angle is the same as this angle. Your angle of depression is when you're on top of something looking down. Here, on top of a building, here's my line of sight. I look down. My eyesight goes like this. I make this guy right here. If we drew another parallel line here, these are alternate interior angles. So your angle of depression and your angle of elevation are the exact same. So depending on which way you built your triangle, it's going to turn out the exact way. And again, this is we're looking for sine, we're looking for an opposite. This is what I'm needing to find, the opposite over, we're needing to find how long this was. This was the piece that I had, the hypotenuse. I won't call it H, I'll say opposite. Okay? Not a lot to do with these. Keep them simple. Keep them really, really simple. They're just right triangle trig. The front of an A-frame cottage has the shape of an isosceles triangle. So even if you don't know what an A-shaped cottage does, make an isosceles triangle. It spans 28 feet high. There's the altitude in the middle. 20 feet wide on the base. This is kind of real similar to number 1. Your perpendicular line cuts that base in half. Your angles in the bottom are the same because it's isosceles, and your base is the same when an isosceles. You want to know what is the angle of elevation to the roof. Okay, so your angle of elevation is always the one that you look up for. So there's your base angle down here. So again, we want an opposite side, we want an adjacent side. If you need to, just redo your triangle. This is your angle of reference. This is always your hypotenuse. This is side opposite, this is side adjacent. And you're just using straight right triangle trig. Nothing fancy. Yes?
Why wouldn't it be at the top, the angle?
Well, because your angle of elevation is when you elevate your eyes this way, you go up. If you're looking here, This is your angle of depression. But if you did that, it is the same exact angle as that. It is fine, because look what happens here. Here's another way to look at it. If you did this, see this little right triangle? Say, for instance, say this angle is 40. What's this angle in here? 50. Oh, these two add up to 90. Oh, that is 40 also. So your angle of elevation, whether you make two parallel lines and cut it with a transversal, or you say which ones are complementary, the angle of elevation and the angle of depression will be the same. Which is kind of nice. So if you see an angle of depression, just make it the angle of elevation and stay inside your triangle. When you come back, I'm giving you a review to do, and then when we come back, we'll do the test. This one, all they're really looking for is your change, is your slope, basically. They're looking, how did this change? So they gave you a nice little diagram here. So it's like a gradient. It's gradually increasing. So you want to figure out your rate of change. Your rate of change is your slope. So we're looking for this guy. Now, this little angle in here is your 9.5 degrees. So if you want to draw this a little bit bigger, that might help. They gave you this, well, this is the piece we need to know. How far from here to here did it go? From here to here. So this is the x. They told you this was 4 miles. You want a 4-mile stretch. How high up did I go? So again, this is your angle of reference. Your angle opposite the right, your side opposite the right angle is always the hypotenuse. This guy opposite you is your opposite side. So who uses opposite and hypotenuse? Sine. So the sine of 9.5, and these are nice because this one worked out, you just have to cross multiply. Sometimes you have to cross multiply and divide, but this one worked out nicely. And see if it makes sense. So this has to be real small, doesn't it? I mean, you wouldn't want this to be a really steep climb on for your car or your hiking or whatever. So it has to be really small, much smaller than your hypotenuse. Because look at how small your angle of elevation is. It's only about 10 degrees. You certainly don't want to climb something a little steeper, even in your car, right? Make sense? Okay, now here comes the big one. We have two things going on. We did the exact same thing in class. The exact same thing. This is an Algebra 2 Regents question. It says an observer from a lighthouse is 350 feet above sea level. Here's your 350 feet above sea level. Okay, it's looking down at two ships. If I'm standing here and I look down, and then I look a little further out, doesn't my angle change? So my angle of depression when I'm here is down here. This is it, outside my triangles. But your angle of depression is the same as your angle of elevation. Now, what was confusing was you had to draw your triangles. So where they all meet right here, drop your triangle line. And when you drop that, and isn't the height of this 350? The height is measured with a perpendicular line. It makes the H. So I basically have two triangles. I have this guy, and I have this guy right here. When I look at the other ship. So now, if I'm looking at these angles, and I'm looking down, here's my 6.5. Here's my 6.5 down here. Here's my 4. Here's my 4 degrees over here. Your angle of depression is the same as your angle of elevation. If you wanted to, you could do this whole thing upside down. You could have dropped your triangles this way. I just don't want to do it and confuse you. And there's your 6.5. This is still 350. I'll erase it and do it in a minute. And drop it this way. There's your 4, and there's your 350. What you want to know is, this guy is this far apart, far away from me. The green is this far away from me. Oh, so therefore, how far apart are those two ships? That's what I'm looking for. How far apart are the two shapes? God bless you. So you basically have two triangles. They're like nested right triangles. They're inside each other. So you have one that says this, 6.5, again, not a big angle, 350. I need to know this distance. Okay, I call this y. You can call it whatever you like. Then I have another one. Who's further away from me? Okay, and again, it has a common height, 350. I call this guy z. Now, when I take these two and I subtract them, won't I get the difference? So I'm going to subtract at the end, after I figure them all out. I'm going to say, well, if this is z, oh, sorry, I need x. I got to do z minus y, and I'll get what my x is. It's the difference between them. I don't have a triangle for that. Last year in Algebra 2, we did non-right triangle trig and found it. Last year, what you probably did was find this piece over here. You found this hypotenuse. And then you did non-right triangle trig and found that piece. We won't even make it that difficult. We just use basic right triangle trig. Through the whole thing, we don't use, in pre-calc, we don't use log sines or cosines. Because we just make it real basic to pre-calc. Pre-calc, we just stick to your basic functions. So again, now, when you cross-multiply these guys, a little bit of a problem. The last time we did it in class, the 350 was on the bottom. So it came out to say 350 times that. It says y times this. Solve for y. Just keep this here for now. Then do the same thing with the 4 degrees angle. Keep this here for now. Then take your formula and just plug them in. And do all your rounding at once. I just have to move this up slightly. And there's your answer. Now, it's not wrong if you did it the other way, because your angle of elevation and your angle of depression are the same. If you took this triangle and you did this, coming out of here, you saw this was your 6.5. Here's your big triangle. Okay? And if you made this like this would still be fine. With your 4 triangle, if you made this one over here, that would still be fine. Your angle of elevation is the same as your angle of depression. So what you just have to remember is as soon as you drop that triangle, that was your 350. And you wanted to find how far apart they were. Okay? Very, very similar to the one we did in class. Very similar. And I know you guys